This morning, millions of Americans are waking up to dangerous weather, from flooding and wildfires in the Midwest to triple-digit heat in the East.
Due to climate change, floods are becoming more frequent and strong. However, emerging technologies now provide us a new hope in predicting and responding to these disasters, especially through AI. Hello, my name is Huang, and today I will explore how technology, in particular AI, and public policy work together to improve disaster prediction and preparedness, with a focus on floods. My research question is, how do AI-based disaster prediction models compare to traditional climate forecasting methods in terms of accuracy and reliability? So one major problem is the lack of river level sensors, like showing in the presentation, in many regions around the world. Traditional models like ARIMA or GCM work only in areas with abundant data, but are unreliable in data-scarce environments. Take a look at this map. It shows flood damage from 1985 to 2003. As you can see, prediction technologies at the time were simply not capable of accurately forecasting floods in many regions. So to solve this problem, Google developed an AI-based flood forecasting system. This model uses satellite imagery, weather forecasts, and topographic data to predict flooding up to 7 days in advance. It can issue early warnings even in areas without real-time sensors, which marks a major breakthrough in global flood prediction. So let's go deeply in Google's AI because we have a time limitation. So at the core of this system is an LSTM-based deep learning model. It learns from the past year's climate and hydrology data to forecast future river water levels. So it has two components here. First, the hindcast LSTM process past data, both static features like terrain and river location, and dynamic data like rainfall and water levels. This information is summarized into what's called a cell state and hidden state. So the hindcast LSTM process past data from time t0 to tx. The second one is the forecast LSTM, takes over using future weather forecasts and the learned information to predict how much water will flow and where flooding is likely. So this result is called the CMAL parameter, and it enables us to visualize potential flooding areas up to a week in advance and even without sensor data. Compared to the widely used GLOFASS system, GLOFASS, Google's AI model has shown improved performance in over 70% of test regions. Most importantly, it performs better in low data environments, making it globally scalable and reliable. This AI system is already in use in over 80 countries, including Bangladesh, India, and Vietnam. People received early flood warnings through websites and smartphone alerts, enabling timely evacuation and response. So, which means it is not just a model, it is saving lives. Flood Hub is expanding to 80 countries, providing forecasting up to 7 days in advance of a flood to 460 million people. In the United States, the Federal Emergency Management Agency, or FEMA, actively works to reduce flood damage through the National Flood Insurance Program, in short, NFIP. Unlike disaster relief, which happens after the damage, NFIP is a proactive policy. It offers affordable insurance to protect homes, renters, and businesses. It also promotes smarter floodplain management practices in local communities. Beyond that, FEMA and NOAA are modernizing disaster response by integrating AI-based forecasting tools. Under the National AI Initiative Act of 2020, U.S. federal policy supports the use of AI in critical areas like disaster management. AI systems now analyze satellites and hydrological data to provide early real-time alerts. So it helps protect both people and infrastructure. So how do AI-based disaster prediction models compare to traditional ones? They are not just more accurate, but they are faster, smarter, and more adaptable. AI-based models, including Google's flood prediction system, it is supported by federal policy, shows how technology can protect lives. For more details, please check my full research paper. Thank you for watching my presentation, and please ask any questions if you have. Thank you.